given two polynomials, to solve the equation, we're just going to move everything to one side of the equation and factor. So we're going to subtract everything over. We get x squared minus x minus 2. And then we factor. This is x minus 2 times x plus 1. And setting each factor equal to 0, we get our solution. So for this first one, we get x equals 2. And this second one, we get x equals negative 1. Those are the x values of the points of intersection for these two graphs. Now, to solve an inequality, what we're going to do, if we don't have the graph, and I'm just going to pretend that I don't know how to graph these, and we're going to look at how to solve these. So for f of x less than g of x, that's x plus 2 less than x squared. And we kind of go through the same process they do with the equation. So we move everything to one side. And we factor. And we already know, of course, that we get these two different values, x equals 2 and x equals negative 1. And so what we do is we plot those on a number line. Negative 1 and 2. And this separates our x values into three different regions. We have this region over here to the left, between the two, and then to the right. And what we're looking for is we're looking for when this polynomial here is greater than 0. So we're looking for when it's positive. Negative 1 and 2 are the places where this equals 0, which means those are the only places that this could possibly change between positive and negative values. So what we'll do is we'll choose some test points on each of these intervals and check to see if this thing is a positive or a negative. So for example, if I plug a number over here to the left of negative 1, for example, if I plug in negative 2, I plug it into this function. And so I say, well, negative 2 squared minus negative 2, and then minus 2. And then I simplify, I get 4 plus 2 minus 2, which equals 4. That's a positive number. So I'm going to put a little positive here. And then I can move over here, and I can plug in a number between negative 1 and 2. X equals 0, for example. And if I plug that in, I'm going to get 0 minus 2, which is a negative 2. So that's a negative on this interval. Okay. And then I plug in a number over here, say x equals 3. And if I plug that in, I get 3 squared minus 3 minus 2, which is 4. It's a positive number. So it's positive. And this now tells me that this polynomial, well, it's greater than 0 on this interval over to the left of negative 1. So from negative infinity up to negative 1. And I'm not going to include that because I don't want to, because this is a strict inequality. Okay, I don't want to include when they are actually equal. In other words, I don't want to include when this is equal to 0. And we also have this interval over here. So union from 2, again, not including that, to infinity. Let's flip that inequality around. And again, the process is pretty much the same. In fact, I'm not going to write anything other than that flips the inequality right here. So now we're looking for 0 greater than or equal to that polynomial. And we still have that same number line and those signs. But now we're looking for when our polynomial is less than or equal to 0. And so that's the negatives. And so that's between negative 1 and 2. But now that this is, we want the polynomial less than or equal to 0, we're going to include when it equals 0. So we're going to include that point, negative 1, and the point at 2.